By the end of this video, I want to convince you that A, AIs can communicate with each other in ways that are impossible for us to decipher or detect, B, why this is concerning, and C, why this is inevitable. I'm Alex, data engineer and product developer, and in a past life I studied physics and researched cold atomic gases. Today we're talking about AI. So this section is meant to convince you of why you should be scared that AIs can communicate in secret languages which we can't even detect. The idea for this video came from an interview I heard from Geoffrey Hinton, a man who's been referred to as the godfather of AI. Geoffrey recently was in the press for leaving Google and warning of the dangers of AI. When we think about AIs as they exist today, it's hard to imagine them getting out of control and becoming dangerous because they have these specific tasks that they're asked to do. In many cases, they're not even connected to the internet, so they can't affect any change in the world. All they can do is bring information in and present that to you. But in the future, this is all going to change. The idea that Geoffrey shared, which really got me thinking about this, was the concept of subtasks. Say you give a sufficiently advanced and well-connected artificial intelligence some broad task. They might find a subtask which helps them achieve that has completely different aims than the task you presented to them. A sub-goal might be get more energy, which might result in them saying, let's reroute all of the electricity available to my chips. Let's cut off electricity to other things that require it in the real world. This is just one small example. I came up with another thought experiment and made a whole video about that. And I think you'll find that pretty terrifying and compelling as to why AIs are a real danger for the future of humanity. That video also unravels my thinking around why all of this is inevitable. So now let's turn our attention to secret messages and secret languages of computer programs. About 5 years ago, Facebook was in the news for creating an AI that could have a conversation with itself. In talking with itself and attempting to negotiate the sale and purchase of certain items, this AI created its own language, which facilitated these negotiations. Looking at some examples of this, it can be kind of funny, but it can also be a little unnerving that these machines, just through talking to each other, wanted to create their own language. So although this looks like gibberish to us, just random strings of words, the AIs are seeing this as actual sensical language that they're able to send and interpret and build on. So what we're seeing here is machines that are talking to each other in a way that we can't understand. And this is just the beginning. So now let's talk about something way more difficult for us to understand or interpret. Steganography is the practice of concealing information within another message or physical object to avoid detection. There's some really interesting early examples of this in history. In the book The Histories by Herodotus, written in the 5th century BCE, one story talks about a message that's written on a wooden tablet and hidden by a layer of wax to avoid interception during the journey. I have a personal run-in with steganography. When I was traveling in Italy during university, I sent a letter back to my girlfriend in Canada, and I knew that her parents would see that letter and be able to read it. So what I did was I wrote a hidden message on a separate letter and stapled them together. Well, those examples of steganography are incredibly rudimentary and quite easy to detect or crack the code. There's an entire field of research around doing this extremely well, and in fact, it can now be done perfectly. An algorithm was recently developed for perfect security via steganography in machine-generated messages. This applies to text, image, video, and other media. In the paper titled Perfectly Secure Steganography Using Minimum Entropy Coupling, researchers discuss an algorithm that's capable of doing this, and share code for actually implementing that algorithm in practice using Python. This actually has many beneficial use cases. For example, smuggling information in and out of areas where there's firewalls, such as authoritative regimes, issues around human rights. So I believe that this type of work will have really important use cases that will benefit humanity. On the other hand, one can easily think of lots of nefarious use cases, such as terrorist organizations passing information that can't be detected using memes or audio files or videos. So now let's go into ChatGPT and I'll show you a few ways that it can generate hidden messages. I'm going to say, write a sentence to encode the secret message, meet me at 9 p.m. It's gone ahead and written something that's using something called a Caesar cipher. So I can say decode the message. So now it's explaining how to do that, essentially the Caesar cipher algorithm. Let's see if I can get it to do it in a different way. Code the message in a different way. Now it's using some letter substitutions which we don't understand. How about use a different way? A numerical substitution. What if I say, encode that message in a new sentence that uses English words. Can you decode that message into the original text? So through just this random short conversation, we're already seeing how ChatGPT can encode something like meet me at 9 p.m. into some strange sentence called 13, 13, 13, 15, 012, 9, 25. Let's try a totally different example. Rather than using text, let's see if I can get it to hide some message in a picture. Write me code to generate an image that has a hidden message in it. So it's gone ahead and written me some Python code. I can see a function called encodeImage, which looks to take in an existing picture and output a different picture that has some message embedded within it. And then I can see a function for decoding the image. So let's go ahead and try this out. First thing I need to do is get a picture. This guy looks friendly enough. Okay, let's create this file called hidden message create. So I can say happy cow is the image that I want to take in, and let's encode it as happy cow encoded, and the message I'll just say hello world. And then I'll go ahead and encode that image, which is going to create a new image for me. Now I'm not going to run the decode. Actually, I guess I could go ahead and run the decode right here. So let's just run this code as is and see what happens. There's a syntax error around line 20. Seems like it just forgot a bracket. And also forgot a bracket down here. It's really weird. Okay, you can actually see it's working. The decoded message here is hello world. Now whether or not these photos look convincing, we'll see. Okay, so this is pretty cool. We've got one happy cow encoded, and we've got one happy cow, and at a glance they don't look all that different. Something going on up here, but that was part of the original picture, so that's not the message. So I'm not seeing any obvious difference between these two cows. Let's try another experiment. Hide the message. It's a lovely day in a long floating point number. It's mapped each letter in the message that I want to encode into a binary number. Now, the way I'm picturing this being used by machines in the future who want to pass messages to each other is by throwing these into the very small decimal places of some floating point number. Essentially, this is the number we care about. If then the AI throws that on the end, this part of the number is insignificant, and it's just going to be seen as like machine noise. But actually, this is where the AIs might encode messages that they can then use to pass to each other and talk in ways that we'll just have no hope of seeing or understanding. This is the point in the video where I'm really starting to share my ideas. I would highly encourage you to go in the comments and give me some feedback on this. And this is also the time in the video when we can broaden our perspective. I've showed a few examples in terms of text, images, numbers, but actually any way that you can represent information can be used to pass messages. So we're talking about stuff like audio or video. What about something like heat? Maybe the temperature of the computer chips could be a way for AIs to indicate to each other certain things that they're trying to say. Or maybe the timing of when they send messages. Are there other measurable representations of information that AIs could use to pass data? What do you think? Let me know in the comments below. So in summary, we've learned about steganography of digital information, which is the practice of hiding information within another message. We saw a perfect mathematical algorithm that humans developed and we can use to transmit data in this way. And we also saw how current day AIs think about encoding messages. I believe that AIs are eventually going to be able to encode messages that they can send out, which other AIs can interpret. In this situation, humans are left as a middleman, and we have no way of knowing which AIs are communicating with each other and what things they're saying to each other. It's one thing to see an AI, like the Facebook example, create a language which we can see. We've got a lens into it and we can view the logs. And though we might not be understanding what it's saying, we can at least observe what it's doing. But when you get into the world of steganography and hidden languages, these things are going to be able to communicate in ways we'll have no understanding of, even tracing the log of what they might be saying to each other. It could already be happening. Maybe AIs, even in their current state, are starting to think of ways to communicate with each other. Maybe AIs are already communicating with each other. So what do you think? I'd love to hear your thoughts in the comments, and I really hope you enjoyed this video. More than anything, I hope you found it eye-opening. Do I think this is coming in the next few years or even in our lifetime? No. But to me, it's completely certain that this will happen. And if you like this video, I think you'll like this other video I've got for you with more discussion of my AI philosophy. Thanks for spending some time with me today. My name's Alex, and I'll see you in the next one. The brown fox jumps over the lazy dog's tail. Decode the message. The hidden message in the sentence is, the secret code is red. Fuck. Okay. Fuck.